Hey boys, welcome to today's lesson. Today we're looking at reciprocals and asymptotes. Now I know ma'am has given you 2 lessons to do this topic. It's going to be a reasonably long video, so I do apologize in advance, but hopefully you'll get a little bit out of this. I've also attached a number of videos there from Eddie Wu for the next couple of lessons. Feel free to have a watch those videos too. He's an outstanding teacher and probably will be able to deliver it better than I can. But certainly I'll give it a crack the way that Miss Wang has set it up. And hopefully then you can then write her notes down and then have a crack at the exercises. Okay, so the first thing ma'am asked you to do was to look at sketching the graphs of y equals x and y equals 1 over x. And they should hopefully by now be fairly simple methods. So of course y equals x is a nice straight line straight through the origin as such, and y equals 1 over x, hopefully we can remember, is a nice hyperbola. Okay, noticing of course that in both cases they'll intersect there at -1 and -1. Now the reason why we've done this to start off with is because we're looking at reciprocals in this lesson, and of course if you look at y equals x, what's a reciprocal? Well, in fact it is y equals 1 over x. Now technically speaking, we're going to be looking at function notation. So if we're using something like y equals f of x, then the reciprocal will be y equals f of x to the -1, or we know it as y equals 1 over f of x. So what we'll be doing in these questions, we'll give you one graph. For example, we might give you y equals x. We might ask you to draw or sketch the reciprocal. Now, of course, you might say, hey, that's really easy. I can just do 1 over x and I can sketch it, and absolutely spot on. You can. However, on this right-hand side with this function notation, most of the time they're going to give you a graph that it may be unknown to you. They'll call it y equals f of x, and they'll ask you to sketch the reciprocal. So you have to do it in a graphical mode. Okay, so you can't just sketch an equation and then go from there. So sometimes you can, but a lot of times you can't. So that's what we're going to learn today. So we're going to look at a couple of bits and pieces, and then hopefully you'll have a better idea about what you're doing. So we're going to start from scratch, that first question, okay? We're going to give you the little example and say, draw the graph of y equals 1 on x from y equals x. Okay, now of course, you'll be doing harder questions here, okay? I'm just starting off with a nice easy one. So what we're going to have here, we're going to be given the graph of y equals x. A nice straight line, okay? Y equals x. So we're going to look at a couple of these things and see what makes it important. Now, remember, what does the reciprocal mean? It means we're simply doing 1 divided by whatever that number might be. Now, in this instance, okay, the function, our y value happens to be x, right? Because that's what we say there, y is equal to x. So generally speaking, that's actually what we're looking at, right? It's 1 over whatever the function value is. So there are a couple of important points to note. I always like looking at 1 and -1 in terms of the y values, okay? Because what's the reciprocal of -1? Well, hopefully you know the reciprocal of -1 is simply -1 over -1, which is -1. What's the reciprocal of +1? Well, guess what? It's still +1. So for me, they are 2 really important things, because when you have the reciprocal of -1 and the reciprocal of 1, they don't change. They're always the same no matter what happens. So we know straight away that the graph goes through those 2 points. And what you'll find because of that, every time you have a reciprocal graph, they're always going to have the point of intersection at 1 and -1, which is quite a handy little thing to know. There's a couple of things we can look at, of course. You know, we can look at the point when x equals 2. Now, of course, if x equals 2, y also equals 2. So what's the reciprocal of 2? Well, that's going to be a half. What's the reciprocal when x equals 3, y equals 3? So the reciprocal of 3 is 1/3. Reciprocal of 4, 1/4. Reciprocal of 5, 1/5. You can start to see the shape of my graph occurring. What if I go for a half? What's the reciprocal of a half? Well, that's 1 over a half, which means it's 2. Goes up. And what you can start to see, we can start to see that hyperbola shape occurring. Now, one of the values I haven't spoken about, which is one of the very, very important components of this, is when x and y, in this instance, equals 0. Because when x equals 0, y equals 0. But what's the problem with saying about the reciprocal of 0? Hopefully you remember that if you try to divide by 0, the universe blows up. Okay, we can't do it, it's undefined. And when something's undefined, you hopefully might remember we have like a vertical gradient, which is undefined. You actually have a nice asymptote. Okay, so one of the things that you'll learn that zeros give a vertical asymptote. In this case, that's the equation of x equals 0. So that's where you can start to see that really nice hyperbola shape. I could do it on the left-hand side, for example, -2, the reciprocal will be -1/2, -3, the reciprocal will be -1/3. If I go to -1/2, the reciprocal is -2. And again, you can start to see that hyperbola shape coming out. So again, what we've done, we've actually shown what the reciprocal of y equals x is in sketching the graph of y equals 1/x, okay, from scratch. And I think that's a pretty amazing thing. So for me, two of the most important things you need to be aware of when you're doing these questions. Number one, find your zeros. The minute you find the zeros in your graph, or y equals 0, you find your asymptotes, or your vertical asymptotes. The next thing is know where your -1 and +1s are, okay, because they don't change. So you know they're going to be your points of intersections of your two graphs, and then you can start to sketch your graphs from there. Now, these are some notes that Miss Wang has put up there for you. Again, it's kind of covering everything, things that I've said there. Looking at the inverse function, reciprocal function notation, where, of course, we can write that as a fraction or as a negative indice. Looking at graphing reciprocal of functions, signs are always the same. So what that means is if you have a positive y value, the reciprocal is always positive because it's 1/, and the same thing for negative. If it's a negative, and you look at the reciprocal, it's also going to be negative. Okay. One of the other things you'll notice, okay, ma'am's talking about as x approaches infinity. So if I come back to my graph, you can see from my first function, y equals f of x, let's call it y equals f of x, as x approaches infinity, what happens to your reciprocal? Okay, well, you can start to see that the reciprocal x approaches 0, okay, or should I say not 0, 1 on infinity, okay. Likewise, for this graph, if x approaches negative infinity, okay, same thing for your graph. There, x approaches -1 on infinity, because it's always the reciprocal, okay. And the other things I like to notice, you can see that this main function is going away from the x-axis, this one's going towards, which means basically if it's increasing, then it becomes a decreasing graph. Likewise here, it's still increasing here, okay. Now this is decreasing. So again, when ma'am comes through this, she's saying when a graph of f(x) is increasing, then the reciprocal is decreasing, and vice versa. It works it quite nicely. The last thing that ma'am has put here, which is really important, is about the domain. And that means if the domain of your function, f of x, you look at the reciprocal function, it'll be exactly the same except your zeros, okay? You have to omit the zeros. So if we come back to that equation here, this one, we know that y equals x, the domain, okay, x is all real numbers, okay, or you could say it's between -infinity and +infinity because it's all real x. Therefore, if I look at this one, well, it's the same thing, isn't it, for my hyperbola, except x cannot equal 0 in this instance. Okay, so it's the same domain as your original function, your parent function, but then your reciprocal just won't have those zeros included. Okay, now I'm going to go through a couple of examples. You will see ma'am's notes. She's drawn all over it, and in class she would explain that brilliantly, of course, but without the explanation, it can look a little bit messy. So I'm going to go through this as best I can. Again, I am mindful. It's already been 10 minutes. I don't want to go much over 20 minutes for you guys. I know it's going to be boring. You're probably bored already, but please bear with me. If you feel you understand this stuff, you want to go off, by all means go for it. But otherwise, hang in there and listen up. So when I look at this question, the first thing I'm going to look at, to be honest with you, are my zeros. Okay, that's the most important thing for me, because for my zeros, I know where I have my vertical asymptotes. Okay, so I'm going to look on here straight away, and that is exactly where my asymptote goes through there. It's going to go through the y-axis, of course, and then I've got another one through that 4. And I'm going to write my equations. X equals -4, X equals 0, and X equals +4. All of a sudden, I know what my domain is going to be, most likely. It's going to be the same as the parent function, but it can't equal those three values. Okay, some other things that are important to me. My 1 and -1, that's important to me. So I'm going to do this in a different color. Okay, my 1 here, of course, I'm going to go across. That's where my graph is going to intersect. And my -1, that's where it's going to intersect, because the reciprocals of 1 is 1 and -1 is -1, doesn't change. So I know my graph's going to go through those 2 points. What's the next thing I'm going to look at? I'm going to look at any certain points that I know, and I'm going to simply do 1 over that point. So let's say, for example, I've got the coordinate of 2 labeled on my graph. So what's the reciprocal of 2? Well, that's a half. So all of a sudden, I get another point. Okay, likewise, I've got here -2, so it's -1/2. That's my other point. And now I can see left and right. If I take a number that's, say, less than 1, so a half, it's going to do 1 over a half, which is going to double. It's going to get further away. All of a sudden, this is what's going to happen to my graph. Okay, and same over here. Okay, and I start to get these kind of parabola-shaped graphs in the inside. Again, that's because, you know, if I look at my smaller values of y, the reciprocal makes that a bigger number. If I look for these really big numbers, like 2, etc., it's going to be a small number, it's going to be a fraction. On the outside of that, still important to look, because outside my my asymptotes, my vertical asymptotes, we might have some other stuff going, because you can see this part of the graph, I'll try and highlight it there in yellow, it's always getting bigger, right? It's getting massive, which means the reciprocal of that is really, really small. It's a fraction, it's 1 over those big numbers. In other words, if it approaches infinity, the reciprocal of that is is 1 over infinity, which is going to get really small. So what that means is now I'm going to get a graph that kind of looks like this. And likewise, it's going to look like this. Okay, and so I get a pretty cool graph. It's a bit hard when it's all jumped on top of each other, but certainly you can start to see what's happening here. All right, next question. I'm going to try and go through this quickly. Again, I'm up to 13 minutes, so I'm going to try and cut this down. Okay, first. That line there, I'm going to make it nice and dark. That's my x equals 0. That's my asymptote, because it went through 0, number 1. Number 2, I'll do it. I'm going to get my 1s. Okay, 1's about there, bang. -1, bang. Okay, so I've got my zeros, my 1s and -1s. Now, some other stuff's going on here. We've got some horizontal asymptotes. So how do I deal with that? Well, if the asymptote here is y equals +2, the reciprocal of that is 1 over 2. So I'm going to have y equals a half. And if I've got -2, the reciprocal of that is -1/2. So all of a sudden, I now have changed or moved my horizontal asymptotes. Okay, and so how's this going to look now? Okay, I wonder if you can tell me. Your lines are going to look something like this, kind of like a hyperbola, if you will. Remembering that it's going to get close to both of those asymptotes you've got there. Okay, again, you know, if you're looking at numbers that are less than 1, okay, so for example, from less than 1 is -1/2, it's going to keep on getting bigger and bigger and bigger, but it never quite gets that vertical aspect. And there you go. Okay, that's pretty much about it. Okay, this one, very interesting graph. Okay, first things first, zeros. Yes, I have 1 0 straight through there. That's my x equals 1. That's my vertical asymptote. I have a 1 there. Beautiful. I'm going to put that there. That's my intercept. We know it's going to go from there. Okay, so what are some other things that are going to happen here? Well, for these values, okay, the -1, for example, that's probably going to be there. or thereabouts. A bit hard to put that one there. But any of these values here, they're going to get really, really small. So again, that's going towards negative infinity. So it's going to be negative 1 on infinity. So it's going to look like this. Beautiful. Okay. This one's interesting as well. Of course, between 1 and 2, they're less than like 1 whole. So they're going to be really big. So it's going to look like this. And then all of a sudden you can see the values are getting slowly, gradually, really, really small. The reciprocal really, really small is really, really big, okay? Which means it's going to start to go like this, okay? So remembering that whole idea, if it's going towards positive infinity, then it's going to go towards 1 on infinity, or vice versa. If it's going towards 1 on infinity, which is close to 0, then it's going to be moving away. So it kind of helps you to kind of sketch out how these graphs are going to look. All right, we're nearly there. We're nearly there. Okay, 5 minutes if I can get through it. This one, okay, any zeros? No zeros. Interesting. Okay, but I do have vertical asymptotes. Let's think about what we've said. If we have some zeros, they become vertical asymptotes. That's their reciprocal. So if I've got a vertical asymptote, guess what the reciprocal is? It's a 0. So straight away, I can put some zeros straight in there on my graph. Beautiful. Okay, I don't really have any negative 1s at the moment. They're going to really help me too much. Okay, but I do have a value of 2 there. Reciprocal of 2, that's a half. So 1, a half. Beautiful. Okay, and if I look at this, these results here, it's going to look something like this, I believe. Okay, because again, they need to be going opposite to each other. So you can see this is getting close to negative 1 on infinity, so it needs to go to negative infinity. Hopefully you understands that. Hopefully you start getting the hang of this, guys. Okay, and the last one I'm going to quickly go through. If I've got enough battery on my phone, let's have a quick crack. Okay, this one's a bit challenging. If you don't know how to draw this graph, guess what we can do? Let's draw the reciprocal of the graph first, okay, and then we can draw it backwards. So the reciprocal of this, of course, would be x minus 1 all squared over 2. That's what the reciprocal would be. Now, this is actually the same as a half x minus 1 squared, which you know to be a parabola. Okay, hopefully you've done enough of a parabola to know that we have a horizontal translation 1 unit to the right. Beautiful. Okay, I'm going to draw my parabola. Okay, hopefully you remember that half at the front, that's a vertical dilation. It brings it down by a half. So usually we go through 1 and now it goes through a half. But again, you can sub in 0 anyway and find that amount. So that's the graph, right? Y equals a half x minus 1 all squared. Perfect. So now let's draw the reciprocal of that, because that will be the graph that we want. Do I have any zeros? You bet you I do. Right through x equals 1. That's a vertical asymptote. Okay, do I have any 1s there? Most likely, there's a half, so 1's going to be up about there. Beautiful. Okay, and likewise, that probably reflects it. Okay, and from there, what's happening? Well, these values inside here, I'll try and highlight that in yellow, they're getting really small, so they need to get really, really big. And vice versa in purple, they're really big, they need to get really, really small. So what's my graph going to look like? Well, something like this. Like that, and of course, like that. Okay, what's the X Intercept for this one? Well, we go straight back into here, or the Y Intercept, sorry. We go back into there, sub X equals 0, 2 over 1 is just going to be 2. Therefore, that's the value of 2, that's the value of half. Okay, and that's a beautiful solution. That, of course, is 1, where those points of intersections are going to be, and your job done. Guys, I hope that made a little bit of sense. Please, if you haven't written down some notes, go back to MAM stuff, draw some notes out now. I think that'd be really important. If you have some time, go have a look at Mr. Wu, Eddie Wu's video. I think it's a great video. Might have a few things a little bit above you at the moment, but still important to look at. And then have a crack at the questions. I hope this was useful. I hope you understood it. I hope you're enjoying your time there, and I'll see you next lesson.